Hello eye tracking community, my name is Michael and this video is all about how to clean your eye tracking data. On the screen we can see an eye tracking experiment where the participant walked through an office. This participant read some questions on a sheet of paper and then went to the different visualizations in the room and finally answered the different given questions. On the left side you can see a scan path visualization, so where the participant has focused on on which object or area in the environment. And here on the right side you can see a parallel scan path visualization which shows you what objects the participant has focused on. Time here in this visualization, so in the PSP visualization, time is running from top to bottom, and this little red line here where my mouse cursor is the current moment in time, which is shown here on the left side. At the beginning the participant focused on an area where no area of interest has been defined, so this is indicated here by the column none, and after a while the participant focused on an area of interest which is called special effects. And after a while here, from here to here, on the area of interest called released movies. There's an interesting aspect in the data which we want to discuss today. When we look here, for example, at this section, this section shows data where the participant mainly focused on the area of interest called released movies. This is what we can see here on the left side in the scan path visualization. So I would say, okay, all the gaze points are in this area of interest. However, if we focus now here on the parallel scan path visualization and zoom in with the Control key on the keyboard, and I'm using the mouse wheel, we can see these little fallbacks here. So going from left, from the column released movies, so from a correct detection, to here to the right, where none area of interest has been detected by the computer vision algorithm. So basically there can be now two reasons why this is happening. One is there was a blink with the eyes or some other issues with the eyes, okay? But the second one could be that there are some problems with the algorithm detecting the markers and so detecting the areas of interest. And if it's the second case, it would be great to have a tool where we can smooth out these wrong detections and create a continuous line showing a continuous detection of this area of interest. So the goal is now to fill the gaps which come or which are created by the computer vision algorithm and to smooth out these fallbacks here for better statistical analysis afterwards, for example. However, now comes the disclaimer. The point here is that after the import of the original data, you will change now the data. And you have to have some real good arguments to do that. And if you're writing an article, a scientific article, or if you're creating a report for your customer, you have to argue why you're now changing the recorded eye tracking data. Gap fill now works as follows. Between the data source eye tracking data here on the left side and my visualizations on the right side, I will insert now the gap fill component. So I go here to the data source node, eye tracking data, make a right click, say analysis, say gap fill, and connect now the output of the gap fill node to the rest of the visualizations here, which have been created beforehand. To better now adjust all the parameters, I do some window magic. So I pulling here the gap fill component window out of the others. So I have it in the front, and then I go here back to the other components from before. And now let's have a look here at the gap fill component. First of all, we choose the column where the data is coming from. So I choose here AOI. There are now different parameters of this component which I can set. The first one is here the column which contains the area of interest information. And then I can set up here the gap fill method. We have 5 different methods, and I'm choosing now in this example that gap fill will only be performed if the previous value is equals the following. So I'm really filling some gaps where the area of interest before is the same, or the previous one is the same like the following one. If you want to get more information about these different methods, please just go to the manual, and there we will prescribe all the other methods as well. The gap value is, so this means the value which defines the gap, in this case is none. So that's the most right AOI column here. And the last thing which I can set here is the maximal gap length. And we will change that slightly in a second. So here in the background, we can see the original data. And I'm adding now another parallel scan path visualization showing the gap-filled areas of interest. And what we can immediately see is that gap fill has removed, for example, these gaps here. So the parallel scan path now shows a cleaned transition path of the gaze points over the area of interest. I can change now here the parameters a bit. So I'm zooming out because I want to see the whole experiment. So Control key and mouse wheel again. You can see now 2 minutes of the experiment. I'm moving that here to the left. And now I can increase this gap fill length value a bit. So 6, 7, 8, 9, 10, 11, 12, and so on. And on the right side, you can see that the gaps are disappearing. So I want to clean now this part here on the bottom as well. So let's increase the values. To say, let's say 45 data rows. I'm choosing here these 45 data rows because this means for a recording frequency of 90 Hertz, this means half a second. So 45 data rows might be a bit high here. I'm just wanting to show you the effect, what it means if you're choosing such a high number, because it's equals half a second in the data. The data has been recorded with 90 Hertz or 500 milliseconds, and that's a lot because you're also smoothing out, for example, blinks in this case. And you have really to be careful with something like that. The reason is simple, because you have changed with the gap fill component the data, the original data which has imported into Blickshift Analytics, and you have to have real good arguments why you're doing that, and you have to write them down in the scientific article or on the report afterwards. However, this component helps you to clean your data, to support algorithms which detected objects or events or some other things in your data beforehand, but perhaps not completely correctly. And it helps you then to clean it up, to smooth it out for a better statistical analysis afterwards, for example. Thank you very much for watching this video. If you like this video, please press the like button, subscribe to our channel, activate the bell so that you'll never miss a new video on this channel. And I'm looking forward to see you in the next video.